So this is question 1W from our review, and it's L is equal to L naught multiplied by the square root of 1 minus V2 over C2, and we're solving for C2. So the first thing that I'm going to do, and again you have to remember with these type of questions that there's more than one way to go about doing a question. So just keep that in mind. Just because I start it one way doesn't mean your way is not any more accurate than my way, okay? So first thing that I'm actually going to do is I'm going to bring over the L naught and isolate. So I have L over L naught is equal to the square root of 1 minus V squared C squared. So it's important for you to recognize that that square root sign is not only a square root sign, but it also acts also as a bracket. So that's why the L naught is a division when we move it across the equal sign, not a subtraction. So that's something to keep in mind. Now I'm going to get rid of the square root by square rooting both, or putting an exponent 2 to both sides. So remember that on our left side that this exponent 2 applies to the L, but it also applies to the L naught because I've put this in brackets. So keep that in mind as well. That's one of our exponent laws from test 3. So L squared over L naught squared is now equal to 1 minus V squared C squared. So what we're going to do now, it's up to you. You can either combine fractions with your 1 minus V squared over C squared, but just remember that your 1 is not under C squared right now. So it's really 1 over 1, and so you would have to make a common denominator to combine fractions, which there's nothing wrong with doing, and you can totally do that. What I'm going to do is I'm actually going to move my negative V squared C squared onto the other side of the equation to make it positive. So I have V squared C squared is equal to 1 minus L squared over L naught squared. From here, we can get rid of the denominators if you want, or you can again combine your fractions. Either way, you will have to get rid of your denominators because the variable that you are solving for is in the denominator. So I'm just going to move this up here. So a common factor that we actually have between C squared and L naught squared is actually C squared L naught squared. That's going to be our common factor. Okay, so there's always a common factor, and typically when we're using formulas, it is often the letters just squished together, because when they're squished together like this, it means C squared multiplied by L naught squared. So every single term is going to be multiplied by C squared L naught squared. Okay, so that we have things canceling out. And I'm going to run out of space here because I write very big. So that's C squared multiplied by L naught squared. And then minus, we have L squared all over L naught squared, and we're multiplying that by the C squared L naught squared. So I apologize, I've run out of space there. But now our denominators should cancel out. So on the bottom one here, that L naught squared will come out of our denominator, and we will be left with the C squared on the bottom. So if I clean this up a bit, I'm left with L naught squared V squared is equal to C squared L naught squared minus L squared C squared. So now what I'm going to do is, because it just so happens that all my C terms are on one side of the equation, I don't have to move anything around. But if they weren't, this is where I would have to do that add-in stage and get rid of any, or clump all my terms that have a C in them. So I don't actually have to do that this time around. So, but I do need to factor out that C squared. So what we end up getting is L naught squared V squared is equal to C squared, and then in brackets L naught squared minus L squared. Okay, so essentially all I have done is pulled out that C squared from both the C squared L naught squared minus the L squared C squared, and then what's left is I've just put brackets around it. So if we were to multiply that out again from this line, you should get the line just directly above it. Okay, so now I'm going to isolate for C squared. So C squared is actually equal to L naught squared V squared all over L naught squared minus L squared. Okay, And from here, what we are going to do is we're going to square root both sides because we're not solving for c squared, we're solving for c. So we're going to square root both sides, and essentially now what we have is, I'm just going to erase that square root of c squared and just replace it with a c, because now we've gotten rid of that squared aspect of c. So c is equal to the square root of L naught squared v squared divided by L naught squared minus L squared. And so when we look at the solutions in our when we look at the solutions, keep in mind, and I did say this in class, that the solution given to you right from the review is different than what I've just created. And the reason for that is factoring along the way. And so as long as you're getting to this point, that's where I really want you to be in terms of your simplification. And please be checking my full solutions first prior to the review solutions.